Very good morning to all of you. Welcome to my YouTube channel. Today I am going to teach you the Cauchy's mean value theorem. Basically Cauchy's mean value theorem is the generalization of Lagrange's mean value theorem. We know that in Lagrange's mean value theorem we use a single function, but in Cauchy mean value theorem here we use two functions. So that is why we called it as the generalization of Lagrange's mean value theorem. So this theorem states that if we have two functions, for example f and g are two functions, such that both functions are continuous in the closed interval ab, both are derivable in the open interval ab, g dash x is non-zero, that is g dash x is not equal to 0 for any x in the open interval ab, then there exists at least one real number c in this open interval ab such that f of b minus f of a divided by g of b minus g of a, this is equal to f dash c divided by g dash c. So if we have to solve questions on Cauchy mean value theorem, we have to satisfy all these conditions there. So if any of the condition is not satisfied, we can say that Cauchy mean value theorem is failed there. So next is the geometrical interpretation. So basically the geometrical interpretation of this theorem is same as that of Lagrange's mean value theorem. So from this figure, this is the curve which I had denoted by gamma. So first of all, what we will see, we will suppose that this curve is described parametrically, and we know that parametric form is basically x is equal to ft and y is equal to gt. So where the parameter t is basically ranges in the closed interval a and b. So when we change this parameter t, when we change this parameter t, the point of the curve basically runs from this point and goes to other point. That is, it runs from A and goes to point B. So as per this theorem, or we can say according to this theorem, there exists a point C on this curve such that what happens, the tangent at this point is basically parallel to the chord joining the endpoints A and B of the curve. So this is the geometrical interpretation of the Cauchy's mean value theorem. Next I am going to solve some examples, and I am also going to prove this theorem. So this is the symbol basically for there exist, and this is the symbol for such that. Now for the proof, first of all we show that g of a is not equal to g of b, and because if g of a is equal to g of b, then it is easy to show. So I will write, first of all we show that g of a is not equal to g of b. Now I am going to prove this by contradiction. So for this I will suppose that g of a is equal to g of b. So I will write, if possible, suppose that g of a is equal to g of b. Okay, now we know that both of these functions are continuous in closed interval ab. So I will write g is continuous in closed interval ab. Similarly, second condition becomes that g is derivable in the open interval ab. And third condition is also which one? G of a is equal to g of b, because I am supposing that. So basically these three conditions are the conditions of Rolle's theorem. So I will write here, therefore g satisfies all the conditions of Rolle's theorem So what happens? Therefore there exists at least one real number c in open interval ab such that G dash C, this is equal to 0. So this is from the Rolle's theorem. But as per the condition third of Cauchy mean value theorem, we have that G dash X is not equal to 0 for any X in open interval AB. So by this it contradicts. So I will write which contradicts the result, which contradicts the result, which result? That G dash X is non-zero for any X in open interval AB. So what happens? Therefore, our supposition is wrong. So our supposition is wrong means G of A is not equal to G of B. So I will write. So this implies f of B minus f of A divided by G of B minus G of A is meaningful. Okay. Now I will proceed in the same manner as that of Lagrange's theorem. But here I will take two functions. Consider the function phi x. This is equal to f of x plus a into g of x. So name it as equation first, where a is the constant to be determined such that phi of A is equal to phi of B. Now I will find the values of phi of A and phi of B from equation first. So from equation first, phi of A is equal to f of A plus a into g of A. Similarly, phi of B is equal to f into f of B in plus a into g of B. Now both these are equal, so I will write f of A plus a into g of A. This is equal to f of B plus a into g of B. So now I will simplify it and find the value of A. So after simplification I get the value minus a g of B minus g of A. This is equal to f of B minus f of A. Or I can write minus a is equal to f of B minus f of A divided by g of B minus g of A. So this is the one value of A. So name it as equation number 2. Now as this function phi x basically satisfies all the conditions of Rolle's theorem. How? I will prove this. Now the real valued function phi x, the real valued function phi x is such that first term it is continuous in the closed interval AB. So this is continuous in the closed interval AB. Second condition, it is derivable in the open interval AB. And also third condition is that phi at A is equal to phi at B. So therefore I will write this phi x satisfies all the conditions of Rolle's theorem. All the conditions of Rolle's theorem. So if it satisfies all the conditions of Rolle's theorem, then what happens? Therefore, there exists at least one real number C which belongs to this open interval AB such that f dash C, or we can say here phi dash C. So phi dash C, this is equal to 0. Now I have to find phi dash x. So from I will differentiating equation first, which was phi x is equal to f of x plus a into g of x with respect to x. We get now phi dash x is equal to f dash x and plus a into g dash x. Now phi dash c is equal to 0. So or I can write phi dash c from here, it is f dash c. I am replacing x by c. So plus a into g dash c. Now now phi dash c is equal to 0. So this implies f dash x, or I can say plus a into g dash x, or this is equal to f dash c plus a dash into a into g dash, sorry, a into g dash c. This is equal to 0. Okay, so from here f dash c is equal to minus a into g dash c, and minus a is equal to f dash c divided by g dash c. So this is the second value of a. So I will write here. So from second and third we have so from second and third we have f dash c divided by g dash c minus time. This is equal to minus time f of b minus f of a divided by g of b minus g of a, or I can write it as, I will write here, or f of b minus f of a divided by g of b minus g of a. This is equal to f dash c divided by g dash c for or I will write here where c belongs to the open interval AB. So hence the theorem is proved. Hence proved. So we have solved this theorem. Now I am going to solve one example on Cauchy mean value theorem. So first example is verify Cauchy mean value theorem for the function. Here function is f of x is equal to x square and g of x is equal to root x in the closed interval 1 and 4. So first of all I will write here f of x is equal to x square and g of x is equal to root x. Now I know that from Cauchy mean value theorem I have to satisfy all the conditions. That is, first condition is both the functions are continuous in the closed interval AB, both the functions are derivable in the open interval AB. Similarly, that g dash x should be non-zero for any x in the x belongs to the open interval AB. Then there exists at least one real number c in this open interval AB such that f of b minus f of a divided by g of b minus g of a, this is equal to f dash c divided by g dash c. Now I use these properties and solve this question. So now here a is basically 1 and b is equal to 4. So first of all I will find these values, that is f of a, f of b, g of a, g of b, f dash c is similarly g dash c. So I will write here f of a, which is equal to f of 1, and this is equal to 1 square and which is equal to 1. Similarly, g of a is equal to g of 1 and this is equal to root 1 and this is equal to 1. Similarly, f of b, this is equal to f of 4 and this is equal to 4 square which is 16, and g of b, this is equal to g of 4 and this is equal to root 4 and which is equal to 2. Now I will write, now f and g are two functions such that both are continuous in the closed interval 1 and 4. Similarly, both are derivable in the open interval 1 and 4, because I will find the derivative, and we know that the derivative of this function is, I will write here, f dash x is equal to 2x, and similarly g dash x is equal to 1 by 2 root x. So from this it is clear that both functions are derivable in this interval. Third condition is g dash x should be non-zero for any x belongs to the open interval 1 and 4. So therefore f of x and g of x satisfies all the conditions of Cauchy mean value theorem. All conditions of Cauchy mean value theorem. So in the closed interval 1 4, so therefore what happens, there exists a real number c such that there exists at least one real number c which belongs to this open interval 1 4, such that f of b minus f of a divided by g of b minus g of a, this is equal to f dash c divided by g dash c. So now I will substitute the values of f of b, f of a, f of g of b, g of a, f dash c, g dash c in this equation, and from there I find the value of the c. So name it as equation number first. So now this is the formula. So where f of b, interval b was interval is 1 and 4 and b was 4, so I will write f of 4 minus f of 1, similarly divided by g of 4 minus g of 1, and this is equal to f dash c divided by g dash c. Okay, so I know that f of f dash x is equal to 2x, and g dash x is equal to 1 by 2 root x. So from here, from this I can find f of c, that is replacing x by c I will get 2c, and replacing x by c here I will get 1 divided by 2 root c. So now substituting all these values in this equation, so now f of 4 is basically this implies f of 4 is 16, f of 1 is 1 divided by root 4 is 2, and that is other term was 1, and this is equal to f dash c, that is 2c divided by 1 divided by 2 root c. So after solving this I will get the value of c is equal to, so basically I will get the value of c equal to 15 by 4 whole raising power 2 by 3, and this belongs to open interval 1 and 4.